Okay, this is lesson 4.2D. So a block, we block by similarities. It's important to remember that when we block, we put things together by similarities. And so we usually do that in a randomized block design. And that's where we're going to describe that method. And then you carry out the experiment separately in each block of similar folks in each block. This accounts for the variation due to the blocking variable. So if two groups are similar, so if lots of times we'll block by gender, right? So it's similar to the idea of stratified, but this is in the context of experimental design. So we might block by gender, which means put all the guys together, all the girls together, and we do separate experiments on each one. And sometimes we can see if it's more effective on one than the other. That one treatment may be more effective than another. So, okay, so here's like a typical kind of randomized block design. So maybe you have 10 volunteers to start. It's important to understand that when you block into smartphone users and non-smartphone users, those are not randomly assigned, right? We blocked by similarities. We put people who actually use a smartphone together, and then people who don't use a smartphone, not as tech savvy probably, together. And so, wow, for some reason, there's actually more non-smartphone users than smartphone users. There's 6 compared to 4. The groups don't have to be exactly the same size. That's important to understand. But you block by some similarity. Then within each block, you randomly assign the 2 treatments. In this case, 2 different types of keyboards. So keyboard A and keyboard B. So those are randomly assigned, and those should be approximately even. If it's an odd number, they're not going to be exactly even, but you want to get those approximately even. And then you're going to compare the typing speed for the 2 different keyboards within each block, and then combine your results to see what your results look like. Do they look different for the non-smartphone users? Maybe they like a different type of keyboard than the smartphone users. I don't know. They do better in one than the other. So, it's a very good design to do a randomized block design. It works very nicely. And that's the typical kind of method. Again, you're blocking by some similarity and then doing the treatments randomly assigned inside of each of those blocks. One version of this, which is amazing, is really good. I really like a match pairs design. It's not always possible to do, but when you're comparing two treatment groups that uses blocks of size 2, so we're blocking into individual, like groups of 2, called a match pairs, 2 very similar experimental units. That means 2 people or 2 animals that share some similarity. Sometimes we can do match pairs designed by age, so get 2 people that are very close in age, and that would be the thing that makes them similar. Sometimes I've seen blocks with husband and wife, or with identical twins. That's a really good match pairs design. Those 2 people would be very similar. And also, even sometimes this is weird to think about, but sometimes it's the same person match pairs with themselves. In other words, like I've seen that with a left and right foot or a left and right hand. You might be testing coordination, I don't know, something. And so you can do all kinds of match pairs, but very good design if it's possible to do. And then within the match pair, so once you've paired 2 people together, there are 2 treatments that are randomly assigned. So it's very important they're randomly assigned. The order of it is even important within each pair. But they receive both treatments in a random order. So they receive both treatments, but within a random order. Okay, so create blocks by matching pairs, similar units, just as with other blocking. So we're going to do an example activity of this, I think, in class. But let's start with just blocked. So let's talk about a randomized block design in this case. So this is similar to a problem we did earlier, but we've changed a few things. So do you learn geometry better from online or with a teacher? I think most St. Mary's students will say with a teacher. To find out, a large high school is setting up an experiment. 500 students, 100 freshmen, and 400 sophomores. That's new information. Who signed up for geometry next year. The school's guidance counselors randomly assigned half the students to take the geometry course online, watching videos. The other half of the students will take geometry course based on teacher lectures. At the end of the year, the success of each program will be measured by the student scores on the geometry final exam, which would be the same for both courses. So I think we did a problem very similar to this a little while ago, but we have a little extra information. And now instead of just a completely randomized design, we want to do a randomized block design. So what similar qualities do you see in this group of 500 that you could maybe group them out a little bit or block them, right? So it seems like if you look, the new information we have, there's 100 freshmen and 400 sophomores. So why don't we block by grade level? Does it make sense? So that first, we're going to split the 500 students into a group of 100 freshmen and 400 sophomores. So they're not equal groups, that's okay. Within each block that we've grouped, those two different blocks, we're going to do a completely randomized design, right? So the way that works is, freshmen taking geometry tend to be more advanced there. Okay, so we're going to randomly assign 50 of the freshmen to take the online, and then 50 will randomly assign to take the teacher. Of the 400 sophomores, we're randomly assigning 200 of them to get the online, and 200 of them randomly assigned to get the course taught in person. And so the rest of it is just two separate, completely randomized designs. But first we blocked by grade level, right? So it's a very nice way to do it. I think that's a good setup there, perfect for that experiment. And so this was the part B. Explain why a randomized block design may be preferable to a completely randomized. So why is that? Well, so it's going to account for the variability better. It's going to have less variability. Some of the grade scores may be dependent on grade level somewhat. I don't know, older students process things differently. This may make it easier to determine the learning format is more effective. So it's a better design in this case because there could be significant differences between freshman and sophomore. I feel like freshman year, you're just learning, figuring things out. Sophomores, you know what you're doing, right? So it definitely could have an effect on this, and so I think it's a smart move to do a randomized block in this case. Less variability should be the result. Okay, clockwise or counterclockwise. So track coach wants to know whether his long distance runners are faster running clockwise the track or counterclockwise. Design an experiment that uses match pairs design to investigate this question. Explain your method of pairing. So match pairs, so we're going to match. So what are we going to do here? So it doesn't say anything about the runners. So I don't know if, we should try to match the runners by grade level or something. So what I'm thinking is maybe we do a match pairs with themselves. So each runner runs one lap clockwise and one lap counterclockwise, and we time them. And so if you formally do that, so each long distance runner has 1 mile, race 1 mile in each direction. Some runners are faster than others, so using themselves to pair with maybe accounts for less variation. But it is very important that for each runner we randomly assign the order, and that's okay to just flip a coin or something to see which way they're going to run first, because I think maybe the second mile might be a little slower potentially. So that's an important step. When they have to run it again, they might be not quite as fast the second time. Heads indicate runner was right clockwise first and then counterclockwise second. So you have to establish that before it starts. Allow adequate recovery time. That's probably a good idea, right? So they probably shouldn't race back to back. Give a little time, maybe morning and afternoon or something, and then test them again with their second. If they did clockwise the first time, then they would do counterclockwise. Record the 1 mile race times for each direction, right? So that'd be a very good technique because now we're comparing, if they have enough recovery time especially, they should have pretty similar times. And so we should be able to figure out maybe one way is a little bit better. Maybe they're used to running around the track counterclockwise, and so that's going to be the way they like it or not. I don't know. And so I think it's a well-designed problem. That's your lesson for today.